Okay. Yep. So today we are going to finish the we're going to finish the um, make interface command. So we're going to finish the make interface command, and yep. So in the what we are going to do is, first of all, we have our um, we have our templates here. So by the way, I just finished the make class command yesterday. I was unable to finish it on the stream because this I was just I was like trying out. So now I think I have enough idea on how to operate. So I think we can pick up from there. So today we are going to finish the make interface command, and what the make interface command does is it makes an interface folder, an interface file, and if there is a need to make a folder, it goes ahead and also make the folder and put the interface in the folder following the naming convention that the person specified in the ZAS configuration. So if the name convention, you can see we have the name convention rejects, but things like the extension, so ifc.php, so every interface will have .ifc.php, and they will be in this folder that is in the supporters. So supporters and interfaces here, because that's what was specified. You can see extensions and path. Under path we have interface, supporters, interface. So with that said, we are going to pick it up from there, and yeah, or maybe I can now tell you what I'm going to do. So firstly, for the make class command, there is the transpiler. So the transpiler takes the code that is in template. So this is the template here. So firstly, there is this class template. So you can see here we are going to put all of the namespaces. Here we're going to put the class name, and here if the class does any inheritance, we're going to put it here. Then if the class implement any interfaces, we put them here. If the class use any traits, we put it here. And if the constructor is public, we put the constructor here, like the constructor access modifier here. And then we take this code that we are going to create and return it back. So if you look in the make class command, there is a lot of things happening here, but I'm going to focus more on the make PHP code. So the make PHP code, you can see this is it. We got the class qualified name, then we add the parent names to the namespace. So if the parent has a particular namespace, we're going to add the parent to the namespace here, as you can see. And then we handle inheritance if there is any inheritance we need to handle. So if we extend the parent, you can see we are actually saying class object inheritance extends parent name. This change map consists of everything we have to change here. It consists of this. So these things that are in square brackets and angle brackets are supposed to be changed. So the change map consists of all of that. And then we're going to format the contract. So probably you want to say implement interface 1, command interface 2. So we format the contracts here, and we format the streets here. So we're going to say use street 1, use street 2. And then we're going to format the namespace here. So you want to say use name, use XYZ, use blah 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 blah. And then we're going to call the transpiler to transpile this, and we return the PHP code. So you can see that this class object extends transpiler, and our transpiler extends abstract transpiler. So the abstract transpiler is an abstract class that is in abstracts. So if I open abstracts, you'll see transpiler.a class, which is transpiler.abstract class.php. And this, the abstract class describe everything that are needed, everything that is needed, everything that is needed. And you can see that it is the start point of the whole transpiler. And then finally the transpiler extends the abstract transpiler and goes ahead to implement the transpile method, which will be what everything will use. Currently, if I take you to just give me a bit, let me share something here. Okay, good. Okay. So, like I was saying, this transpile is kind of used by all of them. The only thing you have to mostly worry about is that there is the namespace, so you can see every template in here has a namespace. So that's why it is implemented generally in the transpiler. But then we have to go ahead now and work on the change map independently. Then we return the PHP code after we have updated the template code and change those things in there based on what we have in the change map. And if you look at class objects, you can see we have all of these constants here, the things that are in the template, and they make the change map, right? So they become the default change map is this one. So if the user, that is, if we don't specify what these things will be, like the visibility of the compiler, of the constructor, then it should be public, right? If you didn't give us the use namespace, like this namespaces to put up here, then it'll just be hash uns hash. The reason I put this thing here was for further insertion. So if we want to maybe add some trait to a particular class, we can just append the namespace of the trait here, and then do the same thing for where we put use namespace. And inheritance is empty by default, contrast is empty by default. So if they are not empty now, then we go ahead. First, here you can even say something. This, we kind of add the parent to the namespace and check if it is not empty parent. Then you see we update our change map, right? The change map now has XYZ. So if you make if you make the PHP code, there is something you should notice here. The change map plus equal the default change map. So everything that is not in the change map becomes placed in the change map. So everything that is defined by the default change map now gets added to the change map. So if the change map already had something to do with the compiler visibility, then the default change maps compiler visibility will not affect the change map compiler visibility. So that is how this whole transpiler thing work. And to just show you that we actually made we finished the make class command, I'm going to use it to make the interface object class, which I've already done here, but maybe I can just demonstrate that to you. So let me say PHP. For now we are still using ZAS.php because we haven't put the code in the PHP in the ZAS file. So it's still ZAS.php, and it's make class. Now we're gonna call it it's gonna be in the ZAS interface, ZAS, or just say ZAS backslash so IFC object. That's the name of the class, and it's gonna have the parent class transpiler, which will be ZAS transpiler, and then finally we're going to have the traits to be from ZAS. We use the namespace utility trait. Yeah, so with that, probably I can open the IFC object. This thing was the thing returned from now there is some little error here, but we're going to fix this one. It was returned from the class object, or the class transpiler. So we converted the contract, not the contract but the template code, into an actual code, and created this file using the system. So the system class is the one that creates files, so it checks based on which operating system we are, and then go ahead to use the appropriate command to create the class and also make directories. So after we made the file, we went ahead now to write the things in the file. So looking at this, I'm going to maybe just use another namespace, not another namespace, but another trait, which is not there, but we will update that later on. There's gonna be maybe ZAS other traits, so that you see what we did. This is how we formatted the trait. And if we want to do the interfaces, we do -I, and we're just going to say from the ZAS interface, do parent interface. So if I run that, you see this thing of this, and you can see that. So it is now class IFC object extends transpiler implements parent interface, and you can see everything gets placed in here. Use other trait, and the reason why you don't see it up here is because other trait is also in the same namespace, ZAS. So that's why it is still like that. So now we know that this class works. The make class function works perfectly, even though we are not finished with it yet, but so far so good. We are just going to go ahead and start using it to make our other classes, so that we don't stress ourselves. So good, now we have it here it is. So we are to implement the object such that it is able to convert the template for the interfaces. So the interfaces template, you can see interface.tpl. We need to convert this interface template into an actual code. So we have to go back and maybe review the class object, which is class object. Let me just say class object of class of PHP. So I'm just going to save all of them, and then we want to open class object, and probably do one or two things, and maybe then we're going to open that one. So since they are almost the same, we can just look at class object and see what we can do here. Now this format method, the format method does something. It is the one that check for it resolves collision. So here is what I mean by collision. Like if we have if let's say you have two different namespaces, but then we have the same name. So let's say you have connector in database, and then you also have connector in maybe WebSocket. Yeah, so you say maybe there is the WebSocket interface. The WebSocket interface has its own connector, so you try to use the WebSocket interface. What we're going to do, let's just create a random class in connectors, not connectors, but just some random class, and then we're gonna say, instead of it's not gonna be IFC object, it's just gonna be some random class like in random. We called it random class. So let's say our random class, our random class. We don't need to put a parent class for this random class, but it's gonna have maybe it uses two interface. So we're going to say the first interface, that's -I. The first interface, we're going to call it random class. I just say random, or yeah, random connector. Random connector. So random connector, we're going to say uses the interface from maybe WebSocket or maybe database / connector, and also uses the one from network / connector. You can see there are two connectors here, and if you were actually programming, if you want to create a new connector, you have to specify that I want to create a new connector from database connector or network connector, which is it's not a problem, but it's inconveniencing. So I wanted to get rid of that. So I kind of used binary trees. So you put these things in a binary tree, and as soon as they collide, we are going to update. We are going to update the binary tree, and that's where the namespace binary source tree comes in. It uses the node, so you can see every node has a namespace array, and then it has a name. So for this one, the name is gonna be connector, but it's gonna have two namespaces. It's gonna be database, and there will be network. So when it is getting into the container we want to put it in, you can see here it kind of checks itself. If it is more than one, then it goes ahead to add a prefix. So let me do that. Let me now let me run this thing. So we're going to create a random class in a random connector.class.php. So if we look into the random folder that has been created by the system, so random connector.class.php is what we have. You can see to handle the collision, we use this as D connector, meaning database connector, and we use this as N connector. So this now will be the class template. So that's how we handled collision, and this is handled by the format. So format, you can format anything. You could format the name, you could format the trait. Yeah, this thing really affects the use namespace string, that is this string that comes up here. That's what the format method affects, but then every other thing can be handled. You can see that it takes in a callback function called the formatter. So this is a function called formatter, and it passes in list and output as references. So these different things like format contract will call the format method and pass their own formatters. So when we have formatted and updated the use namespace string, what we want to do now is, for example, you see for format contract, you are going to see implements interface 1, interface 2, like this. You can see this implement. This is where the contract is, right, in the class template. So it then formats based on this usage. And the same thing for the trait, for the format trait or format. Let me look for it. Yeah, format trait will pass a function that actually takes each value in the output or in the list and say use that value, use trait like that, and then that's what it's going to return. So that is what format trait does. And now when it formats the trait, you can see we update UT. So this particular UT gets updated to become ustraight1, ustraight2. Probably I'll just do that so that you see I'm going to say -t. We're using trait connector trait, so we can say database /connector trait. I'm going to use network /network trait, or maybe connector trait. So this is how it becomes. You see, this was handled by collision because the connector traits are the same. But yeah, this now gets updated, and this one also gets updated. So the main thing the format method does is that it updates this particular use namespace string. Now that we are good with that, we understand what's happening here, at least you can join me to go ahead and create the RFC object. So firstly, for me, I love to abstract things. If you look at this format method, it is really general, and what I think is, since it is general, it will be best if we put this format method in the transpiler itself, because every other transpiler, like class transpiler, interface transpiler, trait transpiler, they will all use this format method to format their namespace string. So due to that, I'm going to take this from here and put it in the parent class. This is going to be transpiler. Yeah. So let's put this here. Now resolve collisions and get namespace text. They are specific. So that means this using the namespace utility. So the namespace utility trait is a trait that has methods for you to deal with namespaces. Maybe get the name of a namespace, probably. Then this one we should put hash ut hash. The main reason we need to put it here is because if we will update this thing using the tool that we are creating, then we will need this thing here. And also here we need hash uns hash, just like that, so that if we have to put use namespace here, the tool will be able to do that for us. So since every transpiler will use the namespace trait, it's better we just take this from here, right? We're just going to copy this, Control C, and then we're going to remove it from here. I'm going to put it in the transpiler class itself. So right below here, let's put it there, and this will have it's going to be traits. Yeah. So the transpiler itself uses name, but then we need to have the resolve collision. So the resolve collision method takes in an array of names and puts them in the NSBSD, which is the namespace binary search tree. And after it does that, it returns them after resolving collision. So this is what it does. Resolve creates a new namespace binary search tree. For every element in the name, we are going to insert the element into the tree. And when we have inserted the element into the tree, then we are going to get the resolve names from the tree. And after we do that, we return the resolve name. So you know that resolve names passes things by reference, so it updates this resolve method. So with that said and done, we are going to put this resolve collision also in the transpiler itself, because it's also general to every other guide that uses it, every other child class. So the good thing is we have the power of polymorphism, so we can go ahead to update these things in the small class as needed. So given that we already have this, now it's the good thing we can look at what we did in here. The constants we initialize at the top of the script. These ones are specific to the class template, but for our interface template, what we only need one thing. Like we need two things actually, or probably three. But then this one is also is general, is defined within the transpiler class itself. If you come to the transpiler, you will see it here. Things like U and S, they are general. UT, it's general. So they are defined in the transpiler class. And what else? Okay, so we need to put some things here now. We need to start following. These classes were not created with the tool we are making, like the way we created the interface object class just now. So we have to put these things here ourselves if we want this class to be manipulatable by the tool we are creating. So now everything here is set, namespace is set. The only thing we need to have the custom thing in the IFC object, which is IN. That's the name of this thing, the interface object. So we're gonna say constant. We're gonna call it is it IN? Now we have to follow the convention here. This one is CN, that one is IN because it's the interface name. It's equal to the way we name it in the template is IN. And I like to keep things formatted. So IN, and then we have the extent, because an interface can extend other interfaces. So we also going to put that in. And you know what? I need to keep this thing open. Oh, but I think it's not going to be long though. Interface. Yeah, extensions. So we need extensions. So interface. This is just gonna be not. It's like, yeah, auto contracts. So it's contracts. Yeah. And this is gonna be ext and xion extensions. Okay, so I kind of think some people are asking, hey, why did you put some of them in angle bracket and you put some of them in maybe square bracket? I was thinking these ones in the angle bracket, you can leave them blank. You don't have to put them there. But these ones here, if you leave them blank, the code won't be able to execute. The same thing for the class. These ones you can leave them blank. We don't have problem with that. But you see, you have to put the constructor visibility. You have to give the class name, and you have to give it a namespace. Sometimes you don't have to, because if the class is in the root namespace, this thing will be empty. So with that said and done, we have created the constants. So let me see how I commented on them here. I didn't comment on them. I need to comment on them. Good. So let's start working. Okay. We need the interface path. So every transpiler must have their template path. So I'm thinking, let's see something. If I take this thing and put it in the parent, does it extend to the child? So I'm going to take that and put it in the transpiler itself. don't know if it does extend to everything, but let's look at the ZAS helper because we actually set the template path in the ZAS helper. When we, yeah, here it is. Oh wow, there are some changes I made yesterday. It's like I didn't push them. Okay, yeah, this one works. So there are some changes I made yesterday because this particular code you are seeing here is gonna be repetitively used by every other things like make class, make trait. So I think I put it in a single function, but I will come back to it. I didn't push the change from the other computer, so that's why. But anyway, now we have the opportunity to do that together. Yeah, it's just my ability to see that something will be repetitively used and try to generalize it and maybe put it in a function so that I can reuse it over and over and again. Or put it in a parent class maybe because yeah, now we have temp path here. That means everything has temp path. Good. What else do we need in here? Everything has default change map. Yeah. I'm going to be looking at this. The interfaces. Yeah, we need that. We definitely need that. Why did I? Okay, so the reason I made this thing protected, by the way, is because when you want to make an abstract class is exactly the same as a real class. So I just have to extend the class object for the abstract class object that you're going to see. It's going to be a C object, probably. I'm going to call it like that, or abstract class object, or a class object, maybe that would be better. So that's why I made this thing protected, because currently I was even thinking, hey, why did I make this thing protected? So now this one is not going to be protected in the interfaces, like in the interface object, because, and I'm sure currently I should be commenting what I do here. So constants defining what should be manipulated in the template, in the interface.tpl. Now, something you should note: these templates are in the dev folder. So at the end of this thing, when we make the ZAS tool, when you tell it to make your application production ready, it's going to go ahead and remove this template, this dev folder. Also, it's going to remove all of itself, every folder that has ZAS in all of the container folders. It's going to remove it, and so you're going to have your code without any of the ZAS tool. And after all, probably you will still have the ZAS PHP, and then you might have to delete it yourself. Yeah. So that's the plan actually. So an array of interfaces implemented by the interface. That's basically it. Let me see, what else do we have here? Okay, so the use namespace string is an array. Use namespace string. Is use namespace string in here? No, it's not. Now let me see. If it is not, then some error might arise. Yeah, you can see. So then use namespace string should also be general to all of them. So this use namespace string should be in the transpiler parent class. So good, we have it in the transpiler. Now it should not cause an error here. Yep. Okay, good. So everything has a use namespace string. Everything has, what else? Everything has parent. No, not everything has parent. This one has parent. It has qualified name. So the qualified name is the full name from the interface to the So our interface must have a qualified name too, but then every other transpiler must have a qualified name. So I don't know, should we bring the qualified name here? Yeah, every other transpiler must have a qualified name. So we are going to get that from here. It's going to be the qualified name of the container. So we're gonna this one is use namespace, right? So down here we're gonna say the qualified name of the container. Qualified names include their namespaces. Good. This basically means trying to abstract things away. So like I wrote most of them here. And now given that I've removed some of these things, I need to take their setters and getters. And yeah, like this one. I'm going to take that one. I'm going to take also the use names. Yeah, all of this one. I'm going to put them in the transpiler class. Yep. Okay, good. Now that we have it, qualified name. What else? Everything has a qualified name. Everything has a use namespace. Everything. Not everything. Okay, yeah, not everything has use trait. But then, if there's any UT, we know what to do with it. So everything has a default change map, and everything has a change map. Now the change map was defined in the abstract transpiler. This transpiler.a class. Now that's the naming convention followed by ZAS. So if you say make abstract class or make AB class or make A class, we'll change the command to make it short. So make A class, you just give the class name. It's gonna be the class name .a class of PHP, but then we are going to put the abstract keyword before it, so it's going to be like abstract transpiler. So you could say make abstract class transpiler, and then it will create abstract class, then it have abstract compiler transpiler, and this is used by the autoloader, and also is referenced in the config. You can see that an abstract class regex is abstract followed by many character. So if you update this thing in the future, then you must make sure that the different things you do change this configuration. Probably we will have to write some methods to change the configurations for you, so that you don't have to worry about writing changing this namespace stuff by hand. You just say maybe set convention regex or convention regex and things like that. Now that we have that, let's go ahead and we look at interfaces. Yeah, namespace util trait, yes. This one is set, right? Perfectly set. So this thing should extend the parent transpiler. So I'm going to see how I did it for the constructor in the class, so that, yep. So we pass in the array change map, and then we call the parent, and then we pass in the change map and the template. Oh, okay. Abstract transpiler takes in a template. Oh, so this is it. I didn't know. So what I'm going to do, I'm going to just copy this thing here. Let me Control C, and I'm going to paste it in the constructor itself, and then we can pass in array change map. Let's click Control Enter to document this for us. So it takes an array change map. And what does change map have? Let me come here and see the same documentation. This thing's supposed to be, not supposed to be, this particular comment should not be over there, it should be over this function, over the constructor. So I'm going to put the same thing here. You see there's no lot of changes. So it makes a new interface object. Makes a new interface object. Okay. Good. So the change map, okay, the change map should contain the class name, and it's going to be class name. So in our case, our change map should contain the interface name and the namespace denoted by CN. CN denoted by, in the namespace denoted by IN implies interface name. And the namespace ZAS server, for example. So with this, we know that we don't have any constructor. It's going to be class object. It's going to be IFC object temp path. Do we need to say IFC object temp path? Okay, it's okay. Let's say like that. We know UNS is just like that default change map. There is no visibility in an interface, so we're just going to clear that one. And also there's the UT. This one, we know there is no there is use namespace, but there is no UT in our traits. So not even our trait, in our interface. There's no inheritance. Okay, there is inheritance. No, it's not. It's contracts. It's contracts. So there's no. It's just contract and interface name. So this one won't be that. It's gonna be IFC object. IFC object. The same thing is gonna be here. So I'll just rename them once. IFC object contract. So by default, there's nothing in here. So yeah, this is the it's the constructor. Now, what's the next thing we want to create? Let's look at the class. We want to override the make PHP code function. So we want to have public make PHP code. Make PHP code does what? This transpile, and then we get PHP code. So the make PHP code is not defined in the parent class because every transpiler has its own make PHP code. However, we can no, we don't have to make transpiler abstract. Let me see the abstract class. Does the abstract class have make PHP code? Yeah, so transpile is abstract. Make PHP code, get PHP code, return the PHP code. But make PHP code, so there's no make PHP code here. So I want to make an abstract function make PHP code so that then that means transpiler will have to be abstract. If transpiler is abstract, then it has to go into the abstract classes. You know what? Let's just I don't want to put transpiler in the abstract classes. It was very, very cool because if we put transpiler there, then there's no need to have transpiler. But we can create an interface called maybe it makes PHP code, yeah. So we can say it's not a coder, it's a code maker. Yeah, code maker interface that makes PHP code, and it should it implements this thing should implement it. Set the transpiler, then the transpiler will leave it to be overwritten by the children. But the problem is, make PHP code might take different parameters for different transpilers. Make PHP code even though we have make PHP code here, it doesn't take any your class. Let me give me okay. So let me make PHP code. This is not gonna return nothing. Okay, good. Make PHP code so that every code maker, then we don't have to code to. If we can code to interfaces, like you know that this thing is a code maker and it's gonna give you a PHP code. It depends on what type it is, and that can be none of your business. All you need to do is to get the PHP code from it. But let's see, should we do that now? I'm actually tired to go create the interface. Like I'm thinking if it's possible for me to just write what to do. I'm going to write the make PHP code function, then I will use the make interface to create the code maker interface. I'll use the make interface command that we will just complete to create that interface, because I'm tired to follow that convention and make everything. Okay, and given that this is the case, we will transpire after all. We are going to namespace usage, use namespace string, Okay, but then we don't have these ones. Don't have parent here. We only know that if the qualified name is not set, we are going to say, since everything will have a qualified name, we can put, because if I say parent, let me see something. Let me see something like the public function make PHP code. This thing does nothing. I'm just trying to see what can happen if I say parent. If I say parent, now I have to return if the parents have that particular error. We have to exit the method. So then this one's supposed to return false or true. So we're gonna say if not parent, make PHP code to just return false, but that'll be a long code. So I'm thinking let me see how long it will be. If not parent, make PHP code, we want to return that. Okay, that's better. The main reason is we already know there are some things we have to keep in mind here. Our use namespace string. Yeah. Since this is common to all transpiler, we can take these two and let me see what I did in here before I called this. So before I called this thing, I had already ran this one. So that means this is the following setting algorithm. But this one is always at the top, so I'm just going to put that one in the. You can see that there is a transpiler.class and transpiler.a class. So did I put this thing in transpiler.a class? Oh, it should be in transpiler. Yeah, you see, those are the confusions now that come up. Okay. Or probably our transpiler itself is a code maker, but the transpiler doesn't have qualified name, so it's the abstract transpiler does not have qualified name. So I'm going to put that in the transpiler itself, right below the transpile method. So we can say this guy returns the PHP code. Yep, and then I'm going to copy. I didn't copy. I'm just going to cut this from here and then put it here. So and we can't just call it make PHP code. This is not correct. What we're gonna say is can make code. Say like can make PHP. Previously it was what? just make PHP code. So here we're going to say can make PHP code. It's going to be return false, and this one here is going to be return true. Now I wanted to put make PHP code in here, but it doesn't make sense to say make PHP code that returns true or false, right? So it's just we just ask if we can make PHP code. So here we would say if our parent, now it's not even our parent, it's just if this can make PHP code. If this can make PHP code, that is not even if this can make PHP. If not, if we cannot make PHP code, then we should return. Then we can put the same line of code in our class. So if we cannot make PHP code, then we should return. Then we print out the message that we cannot make PHP code. And with that said and done, we can clear this guy. So I need to comment properly in here that this thing checks. Can checks if there is a qualified name, and that we can proceed to make the code. So yep. Given that is the case, we can go now here. So checks if there is a qualified name and that we can proceed to make the code. Yep. Now we have our username space string, but before we do that, we need to format contracts. So since we know contracts are like this, but they are actually like that, we can go ahead to format the contracts. So I'm going to copy this function from the class. You see, there's a lot of things that almost look the same. So I'm going to copy this one, and then we're going to put it in here, some part of down here, and then we're going to customize it. So this change map. So we have a change map, right? So we're going to say IFC object. The contract is equal to format. Now we don't have interfaces, so we need to set interfaces. So that means yeah, we have interfaces for this thing, but we don't have any getter and setter. So let's create that quickly. So we're gonna just insert getter and setters down here. Yep. Set interfaces, get interfaces. Let's see how that works in our, yeah, there's not a big deal about it. So good, since we have managed to set interfaces, oh come on, now we have set interfaces. So given that the interfaces are already set, we are going to change map this contract is equal to format this interfaces list, and exactly the same thing. We didn't need to change a lot of stuff here. So I'm just going to say formats FAC interfaces. So these are extensions, but they cannot implement. It can only extend. So this should not be implement. It's supposed to be extend. Let me see. But before we do that, let's check the browser if we can actually like find the syntax for extending interfaces. So what I'm gonna do, let me I'm going to share my browser quite soon. Okay, I'm going to share my browser twice. Okay, and let's go. Okay, okay. Give me a minute. Let me clean things up. Before we go. Okay, so I'm just going to see if I have a browser window open for browsing, and I'm just going to put that here. Yeah, let's make that visible. Can you see it? There is a it's not working. So here what I'm going to do, I'm going to just search for extending like interface extends other interface extend other interface PHP. Okay, good. Okay, now we have to use yeah, that's it. It's supposed to just be extends. I was just overthinking about it. Probably I might be getting it wrong, but now it should be extends. Extends like that. So if that is it, there is some point where we had to override the changes from our two change maps. So let me find that point. Oh, okay. Now even me, I don't know where I actually made the changes to overwrite, but I think it's in the transpile. It's in the transpiler that I made the changes to overwrite. So let me look in the transpiler, and probably that's where the changes overwrite. But I don't know where I made the changes to overwrite clearly, so I have to really check. This is format, it's make code transpile. Let me see. Yeah. So what to do, I'm going to comment this thing here. I'm going to put a comment here. So overwrite change map. So overwrite the change map. Yeah, exactly, that is it. So since we have it already overwritten, this is what we have to do for our interface object. So interface, now it's gonna return an interface code. but there are some errors. I'm saying parent name here, right? It should be for interface object. Good. Now there are no errors. I thought I made an error though. But yeah, there is no error. Did we format interfaces? No, we didn't. We're actually supposed to call format contract right under here. So we're gonna say this format contract, and when we do that, we have already yeah. So now this is it. This is it. This is it. This is it for interface object. This thing I'm not sure is quite correct, but we will see that it's correct later on. If that's the thing, that's why we test. Good. Now this thing I wanted to abstract it away, like this whole place, because I find myself reusing it over and over and again. So what we're gonna do, I'm going to just copy this from here. I'm gonna put it in a method, and the whole thing this code is actually doing, let me just explain it to you. The first thing we do, we get the namespace from the class name. When we get the namespace, the next thing we do is we get the home directory of the namespace. So probably if the namespace is ZAS, we want to know where is ZAS located. The ZAS is located in classes / ZAS. Okay. So if we get the home directory, then the next thing we want to get the actual name. So when we get the actual name, we want to make the home directory a full path, not just classes like supporters / classes / ZAS. So we want to make it come from the root, like from the root. If you look at how roots, root path are, like let me take a look at what we did recently. You can see here, from here. So when we take the home directory, the home directory gives us this path. Here, up to there. Now we want to add up to here. So from the root up to there, and then now we put the class name afterward, or the file name. And then we are going to create a new system, because I told you the system is the guy that makes the files based on the operating system. Then we create a new system and tell the new system to make our directory. And when we make the directory, we're gonna tell the new system to create a file. So we call the system core. You can see here, core. You need the core that we are running on. Like that's what I decided to call it. And then we return. That's all. So this thing is gonna be the same for every other thing, like make interface, make trait. So what I'm gonna do, I'm gonna cut it from here. Yeah. I'm not gonna cut it. Let me just copy it first, and then I'm going to put it in a function, in a private function. So private function make file. So make file, it takes some parameters, but we are going to figure that out as we go, because it's going to get read. So we want the qualified name, which is a string. And the other thing that really changes here is something you should pay attention to. This one here. We have the ZAS configuration object. And this ZAS configuration object is taken from this ZAS config JSON. So this whole thing here is converted to an object. So we have this object, and this object has extensions, and then we have class, abstract class. It also has template path XYZ. So you want to do the same thing here, right there. In our ZAS helper, where are we? Here. So because sometimes it will be interface, so you want to change this thing to interface. You don't want it to be get a path to a class. You want it to get a path to an interface. Now, if it is for the extensions, you want it to be the interface extension. So I already have these things defined in the constants class. So if I come to ZAS constants, you see all of them: ZMake, ZClass, ZTrait, ZAbstract class, it's AB class. But this is going to be some hell of a problem later on. Should we call this thing AB class? Okay, yeah, it's AB class. But I don't think I don't think this is gonna work. These are basically for the command line. So these are command constants, and so they should not interfere. So what I'm gonna do, instead of just calling them ZMake, I'm going to call them ZC make. It's gonna cause some errors some places, but we'll go fix it. That's why we're here. Let me mark all of them. You're going to see some things become red, and yeah, we'll fix that. So it's gonna be ZC instead of, you can see there are many. Okay, so this first one's gonna be ZC make. I'm just going to mark all of them. I'm not going to waste my time trying to fix these problems. So I'm going to just mark all of them, that, and I put C there. Yep. So it's ZC comma meaning ZAS command class, so that I don't cause things to crash. Yeah, so now we have made it like that, but then we don't want to go ahead passing the string itself. You know, when you pass string letters, sometimes when you make changes, it becomes hard to propagate the change across multiple files. So the reason I'm saying string later is because, for example, if we want to pass class here, we have to pass class in a string. If we want to pass interface, we have to pass interface in a string. So what if you go in your ZAS config, and instead of calling it interface, you give it some other name here? Now what will actually happen? It's gonna crash, right? So we just want to use a constant, so that when you change anything here, the constant change. You just change the constant, and we're good. So these are errors, these are commands, these are dash. So like I'm going to make configuration constants. I'm gonna call them const config, right? So ZAS helper. We know that there is the ZAS config. ZAS config, ZAS CFG. This is gonna be long. Let's look for a short name. ZAS config ZFG. Do we have to even say ZAS? Yeah, there will be many configurations, so it's better we call it Z. Okay, no problem. We'll just manage with the long name. Class secret of that class. That's what we have in there. Oh, by the way, let me make this like that. So ZCFG underscore class, and it's not going to be class, it's going to be interface. We have the same thing for, it's going to be a class. I don't know how I call it in the ZAS config, but let me look at it. We call it abstract class. Abstract class. ABSTRACT. Abstract class. ZCFG. Trait. Yeah, that's gonna just be trait, because that's how we call it. And then is there anything here? Class, abstract class, interface, traits, or constants class? Constant, so it's CFG. This is going to be constant class, so it's going to be C class, no, not C class, C and ST, or CF constants. I'm not going to put class here. now I remember I'm writing something that other people will be using to make their software, and here I am telling myself I'm not going to write this one. So they are going to be like, but no one really uses, like no one's gonna use this tool. Like I'm the one implementing the tool. So the only thing they will be interacting with is the commands themselves, like make class, make interface. They don't know how the thing work under the hood, except they want to go there. And when they go there, it's not my fault. Okay, so ZAS PHP constant, we're gonna call that constants class. So here we're gonna say control sets, constants for the constants from the ZAS config. So by the way, if you don't know what ZAS is, it's just an API structure. So it's one an API structure. It's just some way I tell people to organize their files so that it is easily maintainable and easily, like some securities are built in without any further work to do. So constants from ZAS config file, like that. So we are good with this one, constants from ZAS config file. Good. Is there anything? No, there's nothing. So here we know this will be the qualified name. So I'm going to put qualified name there. QUA qualified name. Yeah, we are fixing the errors now. And then here we want it to be something that people pass here. So firstly, they can pass the configuration path string. So we're going to say string. It's going to be say AS path. It's a path string. So you're going to pass the path string here, and then you pass string say the S path. It's not path, it's going to be extension string. So you can see there are two things. One, there is extension here, and then there is path. So we're going to just now use the ZAS path string here. Now this path string is the one we want you to not pass the string directly, but rather pass the constant, like ZAS config class, ZAS config interface, instead of passing the actual string literally class. So we have like this ZAS config path, then you have class, but that will be defined in the constant. So when you change the thing in the constant, everything changes throughout your code instead of writing it and going over everything. But this is merely, I'm going to be the one using this. So ZAS extension. And then when we have done that, we want to return an array that contains the actual name. That points to the actual name that of the file or whatsoever we're working with. We want to have the namespace. That points to the namespace. We're going to have the home directory. That points to the home directory. Just the reason why I'm returning all of this is so that whosoever finds it useful will go ahead and use it. Now this is also supposed to be file path, not even file name. It's just the file path itself. So it's going to be file path. It's going to be like file path. No, not there. So given that we have done this, let's document this function. So makes a file regardless of its directory. So qualified name, full name of the file, like a full name of the maybe container, including this namespace, and then the path string, path as in ZAS config, use one of ZAS constants, CFG, right? That's what we did. CFG, or the same thing for this one. Extension as in ZAS config, use one of. This is the same thing. Why do I have to write the same thing? I'm even regretting the time I took to write it. So good. Yeah, use one of that. What are we returning? We are returning an array. And this array has an array of actual name. So if I say this, what do we see? We see return an array. We have actual name. No, that's going to be the key. So actual name points to actual name. And namespace namespace points to namespace. Then namespace points to namespace. What else? We have the home directory, pointing to the home directory. Pointing to home directory. And lastly, we have file path, pointing to file path. So let's see how to get here. Yeah, return an array. Yep. Actual name points to actual name, namespace, home directory, file path. I don't know why I always miss the T and the H. Always I do this thing. I'm tired of that. I need to refrain from that behavior. Okay, so we didn't want things to crash. Now we are here. So what we're gonna do before we call class object, now we're gonna say make file object. Now I don't even know the variable name I'm going to give this thing. What do you think? What do you think? What do you think? Do you have any name I can give it? If you're in the chat, what do you think I should call the variable that make the file? What name should I? Okay. I'm thinking. What name? Because we have to perform all of these operations and save the stuff in an object. So I don't know what name I'm going to give it. You know what? Okay, now that's the thing, the art of naming variables. This thing makes a file. So we're gonna say not make file, return file, or maybe made file. Made file, the actual name, made file. Yeah, I'm gonna call it made file. Made file, the file that was just made, is equal to this make file. Yeah, good. So then we can pass in the class name for this one. We already know that it's a class, so we're gonna say ZAS helper. Then we can say ZCFG. What's ZAS helper? ZAS constant. Okay. ZAS constant. ZCF. Good. There we go. And this is the same thing that happens for both of them. You want to be like at the end of the class? Yeah. This is it. ZAS constant and the same ZCFG. But it's not a big class, it's class. Yeah, like that. So if we make file, this means trying to preserve, not to cause errors here. I'm going to say our namespace, right, is equal to, so this thing's going to return an array, and I don't want to be using the array subscript operator for now, so I'm going to cast it to an object. Then that means I can use the arrow operator. So I'm just going to say namespace is equal to made file, and we get the namespace. Yeah. Then our home directory is equal to $made file. We get the home directory. And what? Actual name is equal to, if I see this thing is repeating itself, I'm going to put it in another function. But just put it in another function so that I don't waste my time. Okay. Actual name made file. Actual name. And then finally we have file name. It's gonna be file path. You see, I've done it again. PAHT. That's gonna be file path. Good. With that, the main place we used the file path was here, and we wanted to write the code that we return from the transpiler. Okay, so with all of this said and ready to go, what we're gonna do now is I'm gonna comment this out, and we try to see if we can still make a class. So PHP is there is this one we wanted to make about the random. Let's see if it works. Yep. There you go. So undefined variable $file name on line 132. Do we have any place we use file name? Oh, return file path. Return file path. But then still there are other errors. The other error is one undefined variable file name. Okay. 132, no problem. Thrown in. Wait, there should be an error here. I'm looking for that error. Okay, I'm saying that it works. It works. So we still made our random connector. Yeah, this is good. Very good. Okay, so I'm going to delete that. and we are safe. But not, you see, for me, I'm this guy who's afraid of writing something that repeats itself over and over and again. Okay, so this particular code here is gonna be done over and over and again. So you know what? I'm gonna put that one in a function too. I'm gonna put it in a function. So what to do? You create these variables, initialize them to nothing, and you pass them to the function by reference, and the function goes ahead and update them. So let's see. This is just some pure setup. So we're gonna say private function. What do we do here is to just set returned. Should we take it? No, what? I don't want to put it in a function, and then maybe there's a time that comes I have to do something with some stuff before the next stage. But that means I'm going to copy the same old thing from here. You know what? Just the same old thing. I'm going to copy it, and I think you can already guess where we are going to put it. Yes, you're right. We are going to put it in the make interface. Oh man, come on. After all of that drag and drop, Control C, we're going to put it right in here. Yeah, but there's no class name. It's not a problem. It's not a big deal. Or is it a big deal? No, it's not a big deal. So set qualified name. Oh, so wait, there is the actual name, there is the qualified name. Okay, some of my code is even strange to me, but we'll manage it from there. We don't have parent class, we don't have traits, but we have implement interfaces. Not implement interfaces, but rather extends interfaces. So we're gonna call this one extends interfaces. Let's just be keen here. We know that it's not gonna be class object anymore. We're going to be making an interface object. This is going to be an IFC object. And this time around, we're not dealing with class objects. Let's remove all of the class objects. So it's not going to be class object, it's going to be interface object. Yep. IFC object, good. Now IFC object does not have CN, so we are saved. We go straight for IN. Good. And then the namespace. So we know this is going to be IFC object also. So you see, when you just put things, when you organize things, it becomes really easy. Really easy to just. Now, if we go for making the trait, it's not gonna be any problem. Here it's supposed to be IFC. See, good. So this one gonna make the file, return the file name for us. We get the full path. This is cool. Template path, that's gonna be class. This is not gonna be class. This is supposed to be interface. Because we are saying template path from the ZAS configuration. If we look at, do I have the ZAS config here? I don't. If we look at the configuration has template path interface. So with that said, we are not ready to try to make interface yet though. We have this. let me take a look at what we have to finish. Okay, given that we have already done, like, I think we have done most of the work. Yep, okay, we've done most of the work. Now we have the make interface methods. Good. The next thing we have to implement is the make interface command itself. We implemented the ZAS command class, and we want to, you can see here there are to-dos, right? For example, check if the interface exists. If they don't exist, create them. Then there is something I think I have to pay keen attention to. I have not been paying attention to a lot. So what I'm going to do is, whenever you ask the system to make for you a path, the system should return false if it already exists, but we should give people the ability to overwrite, right? So that means we should take that responsibility away from the system. It's us. So the system will tell us this file already exists, and it's up to you to go ahead and cause trouble with it. So let's go back into the system and try to make that. So we're going to return an object that will have two things. To have, it's going to have, so at return, right? I return array. And we're going to have exists. It's just exists is equal to a boolean, and then finally we're going to have full path. Full path is full path. Like that. Full path is full path. Okay, so what I'm going to look for now is, instead of returning this, we are going to return an array. An array that will give you the full path. Yeah, it's gonna say the full path, this particular full path already exists. So we know we're going to say full path implies that, and that exists is true. So maybe let me just put this thing on a single line. Oh wow, okay. So you can be able to revert your changes. That's good, that's good. Okay, so the same thing happens down here. This time we're going to return full path, but then it didn't actually exist. So return full path, and exist is false. And finally, what we'll do lastly, probably we need to add status. Yeah, there might be error sometimes. So status is also a boolean. So let's add status here. Status is a boolean. Okay, not a boolean, but this one status is true. Status is true here. Status is also true. And then here, status is false, and everything is empty. Okay, not everything per se, but at least status is false, exist is undefined. There's nothing called defined. There's nothing called undefined though. So they're gonna say exist is false, and full path is empty string. Yep. If we have an error, good. Okay, good. With that said, we can now go back to where we made our file name here. So you see, it's where the problem comes. Makefile, yeah. Makefile originally was a good idea. Now it seems like not a good idea, but it was a good idea. So we have the file path to be system call. We're gonna convert that to an object first. We created the file, alright? Now we are going to add that here. So we're gonna have actual name. We're gonna say file exists. File exists is equal to file path. Then we're gonna say file exists. File path exists. So firstly, if there's an error, let's check. So if the file path status, if not that, then we are going to log system error could not create file. Good. So firstly, we're gonna say make file exist. Not even file this exists, and this one should not be exists. It should be exists. S. Put exists S. And the same thing here. Exist is true here, exist is false here, status is true, and here exist is false. So let's go back. So firstly, file exists is that, and then file path. We need to know, is it full path? File path. Oh, come on again. I don't know why I always write the H before the T in path. Let me see. I hope I think FULL, full path. Full path. Full path. Okay. Apparently I'm correct. So full path. What else? We have exist. We have good. So now we can tell them the file exists, and so we will need them to pass a parameter like -f for force, so that if the file exists, we can overwrite it like --f. Okay. Yep. it's gonna be s exists. So now we are returning exists, which is a bool. Exists now, which is a bool. So if you ask us to make a file, you must pass the parameter force is equal to force. Make class that. So if not force, right? If not force and the file already exists, and main file exists, then we're going to log, maybe log, let's say log file class already exists. Class exists. Use --f in your command to overwrite it. So then we are just going to return. Do we return anything here? Usually we return something. I think it's the file path. Just return the file path. And yeah. So this is just us checking. Check if file exists and if we want to overwrite it. So that's basically it. And now if I try, okay, now I don't have the random connector, so let me try making the random connector. There's no error, but if I try to do it again, watch what happens. Class already exists, use --f in your command to overwrite it. So you see, now we need to sense --f. So since --f will be global and to everyone, we need to check it. So for every value in I1, we have to say force is equal to force. Force is equal to force. So as soon as we meet --f, so let me open ZAS constants and let's define --f. D dash. Should we call it dash or should we use underscore, like underscore I underscore P dash P? No, dash P is okay. But if we use dash, it's gonna be long. But there's no problem. Still, it's more readable. --f. Yeah, it's more readable. So we are switching our current value and current value. If it is --f, we'll just say false. Case, but this one does not change any state, so that's good for it. Good for us. --f. Now we're going to say $force is equal to true. I think there is a way you can get these things in let me see. Yep. Now I don't know why it doesn't overlay this other window. I don't know if you can see it. Where is it? Okay, probably I'll just have to remove it. I'm trying to show the browser, so just give me a minute. Let me find it. Yep, we good. Okay. Yeah. Okay. There you go. There you go. So now I can go back there, and we can maybe search for some things in the browser. Wait, what happened to Stack Overflow? Control F5. Top secret. Ah. No, I don't. Okay. Dan, can you check Stack Overflow and see the way it appears? I don't know how they have styled it, but it looks like some sheet of paper. Okay, so oh, no wonder why. Okay, now it's April Fool. Ah, okay, thanks, man. Okay, so now we actually want to do something, right? What was it? It was getting a command getting options in PHP. Getting options in PHP. Yeah, so get opt supposed to return the option, because I need force to be a global variable when it comes to making containers. So short option, long option. Short option, each character in this is dash. Now long option is dash dash. Yeah. So we are going to say, let me see, get option F HP, meaning you want F has a value, F colon, then H. Let's see what this one say. Long opt require optional blah blah blah. So short option and long option. So instead of I just want to get dash dash F. So since we can just put an empty string, let me see. Okay, so probably I think there's a way which is just put F in there. So I'm going to do that because I want this thing to be global instead of just getting it for make class. It's supposed to be the same thing for all of them. So we're gonna say force is equal to it's gonna be force by default, I think so, because if you look at the browser, if you look at the browser, F required value, short option F, but I don't want that one. Let's go back and read this thing here. An array. Each element in this array will be used as option strings and magic is passed, starting with double hyphens. For example, a long up recognizes. Okay. If the rest index passed, then the index where argument passing stop will be written to this variable. Okay. So what I'm going to do here, I want to say this thing is equal to false by default. But if we get opt, if get opt short option, we don't have any short option. I'll just pass in all over there. Now long option is okay. We can't pass null here, so let me just pass an empty string. And our long option that we want is f, right? But it's not. Is it f? Yeah, it's f. So if there is dash dash f, it's gonna return. Returns a string array. So let me. Oh, I wasn't sharing my screen. I wasn't sharing my screen. I'm going to share it soon. Let me just read this thing. Here they said get option that when you dump options, we have an array of 2. Index f points to a value. H is false for the fact that H exists in the first place. That's the main thing. So if it's set, now you just want to check if it's set. That when you return, you just want to check if it is set f in there. If there is f in that thing, but before we do that, let me see how the long options are. If you try to return long option required bool value, so if it said that, then false is equal to true. So if it is set this, then okay, so we good with that one. And probably thinking how in the world are we going to use that? Yeah, you already saw I put it in the make class command, so now we're supposed to pass it here. I'm going to pass false. So instead of us having that error this time, let's do our dash dash f. Let's see, the error still comes, meaning false was not. So what we're gonna do is let's try to dump this thing here, or not even dump it. We're going to print error. Let's see what we get. Yeah, for me this is how I debug. I like printing out things. It's an empty array. You mean it didn't find dash dash f? Or am I getting it wrong? Wait, long option require. And then why? Do I need to put a short option there? No, I don't need to put a short option. Or required. Okay. So it's still yet not. What I'm gonna do, I'm gonna put I in here. Let's see if it's gonna get I. Still an empty array. So why is it still an empty array? After all, this is still it still has a complexity of n, so I don't even need to be trying to make things fast. So since the complexity is still n, we can just use another technique. If I research if is set, no, that is set is if array underscore search, we want to search our arg value. If array search ZAS constants dash dash f. Wait, let me see. We search for the needle in the array. I've swapped their places. $argv. If we find it, then good and good for us. It seems like we didn't find it, or did we? Let's print R. Oh, this thing returns -1. Let me see. It returns an int string false. So if it is not equal to false, if it is not equivalent to false, if it is not equivalent to false, so there's dash dash f. It is here. So let's print this thing too. Let's print it. So we're going to log that is ZAS helper. Log that. It's found. It is found. Good. So after all, this one is not wrong. So then the problem is now with the logic, because here we passed force. Yeah, we passed force. So then that means the make class is the guy having the problem. So we say force is equal to force, right? And maybe we have to look at we said if force is force, does that mean force is not force? And made-file exists, then log this one, but it is still not listening to that. So let's go to our make, our execute command, and let's see if we are. No wonder why, I just knew. There's the error here. Okay, so now that we have that, we can. So it overwrote. Good. Okay. Now I'm going to do the same thing for the make interface command. So when we come here, you just want to firstly do the same thing, like check if it's a false and blah blah blah. I don't like to do repetitive stuff, but for this case, seems like it's the only thing we can do. Interface already exists. Use --f in your command to override it, and not force. So we're gonna pass force up here. Okay, so if you are implementing an interface that already exists, we cannot override that for you. So let's keep that in mind, because if you override it, some other classes might be using the same interface. So that's one thing we are going to ensure. Yeah, now we have our make interface ready to go. So let's go edit our CMD. So we said class. For class, you can do all of this, and then okay, we can put so here we're gonna put so there's the name, container name, right? Then now we're going to put the I here. Just want to keep things tight, clean. Okay, on this one here is IV4. That IV4 thing is what we used to say in primary school. So even IV, even though IV means 4, just used to say IV4, V5, VI. So that's what's happening to me. So I think I made some errors here. We shouldn't have put comma. It's just space. Let me clean this. These commands. Dash. So say for class, so for classes, and this one for interface. For interface, now you want to use the same -i, meaning not -i but -e extends other interfaces instead of implements. What do you think? Should we use -e? E is edit, ex extend, not implement. We could use -e for extend. dash ex probably. So dash ext now. But an interface cannot have a parent interface. It can only extend. I'm going to use the dash e. Interface 1, interface 2, interface 3. Okay, so okay. Oh, I didn't hide this browser window. No, this is not good. Okay. I'm so sorry. I didn't even know that the browser window was down on the thing. Well, I have a lot to learn. So interface 1, interface 2, interface 3, blah blah blah. That's all for interfaces. So we can just go to helper. What are we trying to fix? We're trying to fix force. Yeah, and we fixed it. What? And you have not been seeing that all along. Okay. But just know that we fixed force. So what happens is we're making an interface. So we're gonna come here again to the same old thing. We're gonna have interfaces because it has other interfaces. So we're gonna say interfaces is that. So we're gonna do the same loop, but this time so there's a fourth argument we already know. It's gonna be dash e. So current val if the fourth argument is not -e, is there anything you can do for an interface? Maybe you could create an interface and say some classes should implement the interface. But that one will be for later. So for now, we'll just search for E. So we're gonna say is interface list second first. So should we switch? Yeah, we switch. Case -e. It's no longer -i, it's actually -e. Although there's no -e, but continuing to now we're just going to put -e here. Okay, now if it's -e, we're going to say it's our interface list is int list is equal to true. And then we're going to do another switch through this time. Case, there's only one case here, but trust me, it's going to increase that. That's why I'm just leaving it like that. It's int list. It's int list, it's true. What do you want to do? You want to put is equal to current value. Now, why did I even say it's argument I should just have said current value. What was I thinking about? Let's go to current value. Yeah. Because we know that we always update current value. So it's gonna be like that. And when we're done with all of this, we're gonna come here. Then I'm gonna call this. Let's call ZAS log make interface. I'm going to give it a container name. Extend interfaces, I'm going to give it interfaces. Guys, this is it for make interface, or is it? So we're gonna test, right? We're gonna test. Like I told you, I wanted to make that interface of the one for making PHP code. So let's test it on that. So we're gonna say PHP ZAS.php make interface. Yeah, like a command. So make interface. What's the name of the interface? ZAS / what? It's called code maker. this guy is a code maker. It makes code, man. Code maker, and we're gonna say dash. Let's see if it works in the first place. No problem. That's how we start. Whew. This is going to hurt. This is going to hurt. I put the stuff after here. Ooh, guys, there we go. There we go. Look in the interfaces folder. You can see there is the code maker.ifc.php, and let's see what we get. We get interface code maker. There's supposed to be interface code maker interface. We're supposed to follow the naming convention, and that will be the next thing we do. Oh, because I'm feeling like I want to sleep. So we made the interface, yeah, true. Okay, but let's just see if we can also put parent interfaces, because we don't want to have this dash extends parent. Oh, I need to use dash dash f. Oh, okay, this one does not exist in interface f. Now this is an error, by the way. That is an error, so we want to be sure that this thing is not dash dash f. Okay, so what we'll do is, when we have the index in here, when we get the f stuff, right? So we're gonna save that index and then change it. So let's say false index is that. So if therefore index false is not equal to that, then we just going to say this is true. These are problems that just pop up randomly. Then we can update that in our I don't know if our argument, yeah, it is writable, it's ours, it's not from the command line. So no, I'm not already there, but this has called me. False index is equal to we can't change false index to an empty string. So we want to unset. Let's unset this. We want to unset false index. That still leaves us with another problem. If we unset false index, it will be empty. So while we are less than that, we just want to be sure that we are not empty. Or instead of using argc, we can reset argc here by saying argv is equal to, okay, argv is equal to array values, and array value of argv still, so that we don't cause trouble. And argc is equal to count, v, because if we unset that thing, the index will stay there, but there will be no value, and then we will have ourselves creating something that should not be created. Good. So now we should not have the code maker interface and stuff. There you go. Okay. So guys, we are almost there. Almost. So now we are thinking, where do we add the interface to be at the end of the name? Technically, that should be in the in the interface object, probably not in one of these functions. And it's up to the coder to not put the interface. However, we need to get that from I'm looking at the autoloader class. Let's see, how did I do this thing here? It was some magic, eh? See, I was updating the regex. Hey, I don't know if you see what I did here, but I was I was taking the regex. This was for me to get the actual name. So so if it is abstract class, I wanted to replace abstract. So that means the same algorithm I used here, I can use the same algorithm. We take the regex, right? Even though I've forgotten what I did over there, but it's part of the stories we have to tell. So now right before we call the transpile, we can change the name, right? Update the name like that first. We already know the regex is in the ZAS configuration. There is some train passing outside there, so let me see if I can. Okay, so we actually want to get what is in the ZAS configuration and use that. So what to do, I'm just going to, I will take this from here. I'm not going to update the name here. We'll update the name in the individual maker themselves. So make interface has to update its own actual name. So let me do that. So we are going to say this, we want the conventions regex, which is in here. And I know you are thinking, why can't you just put interface there? The reason is someone can change this regex, and instead of it being like ending with interface, they'll make it to end with int, like. So I just want to get whatsoever they put in here and use that. So let me code to that interface instead of coding to some abstract, not abstract, some concrete value. So yeah, I want to put that right here. So yeah, not even next regex. We're just gonna call this thing regex. This is when you try to to save yourself from naming stuff, eh? That's what I was trying to do here. So we're gonna call that regex. So this one now is not, we are not break replacing anything. We are just putting, we're putting the regex at the end of this thing. So dot equal regex, like that. This one I'm not sure it's gonna work, but we'll try our best, eh? Ah, it worked. It worked. It worked. And we have some very few changes to make. You want to know the changes? That's very few changes, but just very few improvements. Very few improvements. And let me tell you what are the improvements. You see, when we call make, you see we have to do check here. It's the same thing. So here, for every interface we see, we have to make the interface. If the interface already exists, we won't make it, so it's fine. So make every interface same. So we're just going to say this make interface, and this interface is going to have current value name. It's going to be, we are not, it's going to be a full name. If it's not a full name, it's not our fault. There are no interfaces, and we are not overwriting anything. So if the parent interface does not exist, guess what happens? We are going to make it. Look at that. Beautiful, right? Look at it. Can you see? There is the parent interface. You see it? Parent interface. Like, that's why we say do not put interface there, because if you do put interface there, we are not going to remove it. You're going to remove it yourself. I'm not going to be the one removing it, because I can't remove something and then add another thing there. If you say parent interface, it's going to be your own fault, not mine. Good. But yeah, but then there's no use namespace. Okay, yeah, in parent, but then in here there is use namespace, parent interface, but then they're supposed to be capitalized. So we're still going to do some little changes, little improvements. So when we make the parent interface, we need to get the name, the actual name of the parent interface. Okay. Because for now we are returning the full path, and who has time for the full path? Do you need to use the full path? No. So what to do? We want to return an object again. Do we really need the full? Okay, maybe. Let me just leave it like that. And then we're gonna call this one the actual. So we're gonna have the file path. File path is that. And then we're gonna have the full path. That's the full path for the actual name. Actual name is $actual name. I think this is what we're gonna be returning from all of them now. Okay, so if we find ourselves needing, because when you make, for example, the parent class of something, if you make the parent class, you want to put the parent class real name, not the parent class name that was passed. So that will make us, for every interface we make, let's come here. For every Now when we meet the parent, we need to check if the parent exists here. So just check if the parent exists. So we're gonna say that our parent actual name hey, there's a big problem here. If the parent already exists, then we won't return the parent actual name. And we should be able to return the parent actual name. Okay. Okay, so don't worry. We're gonna fix this. This one's not gonna be a problem. It's gonna be this make class, and it's gonna be the parent, the current var, which is the parent name. And does the parent have a parent now? Does it have any interfaces now? So everything here is just gonna be default. We're just gonna make that, and we are going to return an object. Let's say parent. We're gonna return an object. That's gonna be an object. So parent object, no, parent class. We're just gonna get parent actual name. Actual name. Okay, so probably me too have been wondering how am I going to do it, but I just realized that there is just one thing I have to change. So you see, the main thing that we are looking at here is overwriting. There's nothing else, it's just overwriting. So instead of putting if it is not false and bit file exists, we're going to take this thing from here. We are going to bring it here. So instead of returning, we won't return. We will say if it's false, if we are forcing it, whether the file exists or not, we want to write to it. No, not really. Okay. The exception is if we are forcing things, then we want to write to them. Okay, if the file already exists, we want to print a single message. Then, if the false is not there, we won't write to the file. If makefile exists, we're just going to do this. Like that. And then, if it is false, okay, if now sometimes false cannot be there. So if makefile exists, we want to do that, but if makefile exists and it is false, then you want to write to it. Or this is something that has to do with an OR case. First, we check if we are forcing and the file exists. But if we are not forcing and the file exists, we don't want to overwrite it. So there are two cases. One, we force while the file exists, and two, the file does not exist. So or not makefile exists. So if none of these, then we're good and we can write. to the file, because that's the main thing we're trying to prevent from writing the new code to the file. So it's better we protect that. So now, given that, we can just return the actual name and the full path. So with this said, we can do the same thing for the class, for our classes. So we're going to do Control C, go to the classes, and instead of this one, let's delete this one. Yeah, these are the improvements that come, man. They just come. You find yourself wanting to extend a code, and then boom, something you wrote earlier on, thinking that it was the best, has proven to be the worst. It's like, I'm going to prohibit you from moving on. You just have to change it. If you don't change it, it is your fault. Class obj. So class obj, we write to the file, then return the actual name and the file path. There's nothing. With that said and done, we can now go back and peacefully, in peace, write our code. At least nobody will say. So now this thing here, checking if the interface exists. We're just gonna say interface is equal to an object from this make interface. We're going to pass the interface name to be current val, and it extends other interfaces. No, that's supposed to be a default array of nothing. So I'm just going there to put nothing. I like the way I said it. I'm just going there to put nothing. Yeah, I'm going there to put nothing. Introducing nothing. The nothingness of everything. Okay. This is something just me having fun here. So if for every interface we see, we're going to make the interface, and then we say interface. What do we do? Interface, interface is actually. Yep, like that. And that's how it's going to be, even for the trait that we are going to work on later on. But it's good that we are able to make interface. We're not going to put current value here. I'm going to put interface. And we're going to put interface actual name here. Like that. So wait. Oh, this is supposed to be an object. And probably I didn't update the return value of these things. So let's go return an array. We return an array, right? And that array has actual name, and we have full path, so file path. I've made a mistake again, another one. Let's see, the time is 6:40. Okay, I'll soon be ending the stream, and we will pick it up from there tomorrow. And now the thing is, when I go, I will usually work on this, but today I don't think I will be able to. But yeah, that's what happens. I find myself working on it, and then when I come here, I tell you, hey, I already did this one, so I'm just going to do this. This was file path, not file name. I said file name. No, I didn't say file name. Wow, that's good. File path. So with that in mind, we can go ahead and say, oh, we want to print the actual name. So I'm gonna make this an object, not IFC object, just object. I'm gonna make that an object, and then we're gonna get the actual name. Okay, we need to make this like that, then get actual name. Do the same thing here, then get the actual name, but then we have to make this an object like that, object of an actual name. And let's finally test this thing. Boom. Ladies and gentlemen, get ready. We online 373. Okay, so we've just made another error. 341. ACTUAL. Actual name. But I think we already made the stuff, eh? Here you go, CodeMaker interface. There you go. And let's open the CodeMaker interface. There it is, parent interface, all capitalized, you know. And in fact, we have to remove this parent interface stuff, just say parent. And let's see the magic. There you go. And it's even made the parent.ifc for us, you know. And probably this parent interface needs to be deleted now. But we're just testing. Let's do the same thing for one of our classes we had in the past, random. Let's see if it's gonna make all of those things like database, connector, all of that. Let's see. Ah, look at that. Look at the magic. Watch it. You see the magic? It made database, made the connector interface. Do you see that? Do you see how cool that is? Connector IFC makes the network interface. This is beautiful. Then it went on not to just make the random class. Then it makes sure we implemented those things. Now let's see. Oh wait, we might be having an error here. Implement connector interface. Guys, there is another issue. I might have caused some problem. But why did it only make, why did it put only one interface here? And it's not even supposed to just say connector. Oh, implement CONNECT. Oh wow. Wait. Did it make the connector interface? Did it? It didn't make the connector interface. Why? Connector trait, database -c, connector, network connector. Wait. The trait was correct, but then the interface was wrong. Okay. Okay, we'll fix that other error. we're not supposed to use, we're supposed to use one of these. We're supposed to use database connector and network connector. This is a very big problem. That was working. It was working when we didn't make the interfaces. Now it's not working. Probably. Ah, I get it. So we should actually be returning the fully qualified name, not the actual name. Ah. So yeah, guys, there is another problem. So instead of returning actual name, we need to return the qualified name. So IFC objects get qualified name. Now I just hope this thing's gonna return for me the correct qualified name, because I don't remember formatting the qualified name. But I don't know yet. Let's see. If we get the qualified name, then good. If we don't get the qualified name, then undefined database / connector. Oh. Okay, there is another issue. Another one has popped up. Okay, so for the class, it's not a problem. For the interface, it is a problem. So we shouldn't be putting this on the. We pass the actual name here. So this one should return the qualified name. So let's see. Qualified name. After transpilation, what happened? Yep. Oh. Yeah, the qualified name has, we have to update the qualified name. So we know that there is the actual name, then there is the qualified name. So set qualified name. Let's look at the ZAS helper. We already know how we are going to return the namespace. So I'm not going to Hey. So set qualified name, interface name. And I already know. So instead of, we can actually say namespace backslash. Let's see if this one works. Okay, it's gonna be namespace plus a double backslash actual name. So let's do this. For classes, that's not a problem. It's not a problem at all for classes. But still, we can do the same thing for classes though, so that we just have consistency all around the place. Yeah. Because I don't know. Undefined variable data pack random. Online 115. Undefined variable backslash random online 115. Yep. Now, okay, no problem. We're gonna leave managing until we fix it. We're good now. So everybody works well. Guys. Yep. This is good, eh? This is really good. Imagine if you don't have to do all of this work yourself. Everything. Now we just have to work on the traits so that we are able to make the traits. So you see, with just a single command, you can make everything you want, include them, and it's just, I think, beautiful. I'll even try my best now to kind of allow people to group namespace. So you do namespace, curly braces, and then you put all of the things you want in that particular namespace. Go to the next namespace, like that, so that things get more easy instead of repeatedly writing the same namespace for multiple things or multiple items. With that said, I just need to clean some of these files that I've created here, and let me just delete them. And that's it. That's the end of today's stream. And the code maker interface is here. Wait, what did I just delete? I deleted the database folder. No, control I. Talking about here. Hey, I deleted the database folder. Oh, I will bring it back. Oh, so okay. So, yep. Everything is done.